Hello everyone, welcome to the Faded Insights. In this video, I am going to explain you about the discharging of a capacitor. And one thing I just want to tell you people is that if you not watch the video of how the capacitor charges, please go watch the video. Otherwise, it will be difficult for you to understand the concept of discharging of the capacitor. And one additional thing is that at the end of this video, I am going to show you how the capacitor practically discharges with the help of an LED. That will be very beautiful. Stay with the video if you really want to understand, or if you really need to understand the concept. Okay, so guys, this is the initial stage of the capacitor. This is the condition where the capacitor is fully charged, that is 9 volts, which is nothing but the source voltage. It is charged to the source voltage. So now the current is 0 because 9 volts and 9 volts, there is no potential difference, so the current is 0 in the circuit, which we can also say this is open circuit, or this is in the steady state, or it is blocking DC. The capacitor is blocking DC. Okay, you can observe also the final conditions when the capacitor is charged. There is some positive ions in this plate and and the electrons or negative charges in this place, excess electrons here. Because of the excess electrons, it will become more negative. Because of the positive ions, it will become positive. So this is positive and much negative charge over here, and as a result, when there is imbalance between the charges, there will be electric field between them is present. This is the electric field. I hope you understand, guys. So now what happens is that these electrons always tend to come to this original position and try to balance, but this 9 volt source is preventing these electrons to go to their original positions. So now in discharging, what I'm going to do is I'm removing this guy. I'm removing this guy, and I'm connecting. I'm short circuiting this thing. Okay, I'm short circuiting. Now you can observe these electrons. This electron will now. There is no resistance for this electron to stop, so this will happily travel to in this path and come over here, and they'll balance. Okay, this is no longer be positively charged. It will balance, so it will become neutral. So as a result, there will be the charge will be decreased. So the electric field also gets decreased. Now the voltage also decreases, right? So the voltage also gets decreased. So initially, let's say it decreases to from 9 volts to, initially it is 9 volts and 0 amperes. Now it decreases to let's say 5 volts. Okay, 5 volts. So if it decreases to 5 volts, the current is nothing but this is 5 volts, right? This is 0. Because this is ground. This is 0 volts. 5 minus 0 or 2 is nothing but 2.5 amperes. Okay, again. This electron or this negative charge will come and travel through the original path, and it balances with this atom here. Again, the this charge difference, the charge differences decreases, and the electric field decreases, and the voltage also decreases. Let's assume it to be 2 volts. So this is 2 volts, and this is 2 volts. This is 2 minus 0 over 2 is nothing but 1 ampere. Okay, 1 ampere. So, and one more thing, guys, I forgot to mention. So the electrons are traveling in this direction during discharging, so the current direction must be like this, because the convention is that the current always flows opposite to the direction of the electron flow. So this is the electron flow, electron current, but this is the conventional current. Okay, so this conventional current is adopted to avoid some negative things. This is the current. So, and this is also the reason why in case of discharging, the current direction reverses, but the voltage remains constant. You can observe it from here. Initially during charging, the current direction is like this. This is during charging, but during discharging, the current direction reverses in case of capacitor, and this is the reason why the current direction reverses in case of discharging. Okay, so now the final one, the electron, this will go in this path, and again it will balance out the thing out here, it will balances the thing. So now we can say the voltage is 0 volts, this is 0 volts. Now you can calculate the voltage across the capacitor is 0 volts, and the current is nothing but 0 minus 0 over 2. What is that? 0 by 2. 0 over 2 is nothing but 0. The current is 0. Again it will becomes another open circuit. These things you have to understand, you have to keep in mind. Okay. So the practical thing, guys, I'm going to connect a LED over here. I'm going to connect a LED in this, at this place. I'm going to connect a LED. Okay, I hope you can observe here. I'm going to connect a LED. So the procedure will be repeats. So when it is not discharged, it is fully charged, the electron will come here and go through this LED. So as the electrons glow through this LED, the current is initially, it is 2.5 amperes, and again the current reduces. As the current reduces, the glow in the LED will also decreases. I mean, it fades away gradually. So initially it is 2.5 amperes, and 1 amperes the glow of this LED will decreases or fades away. So when it reaches 0, the LED will also the LED will gets off, or it will be put out. So this is the thing that I'm going to explain practical. That is practical. I'm going to prove in case of discharging of a capacitor. So guys, this is the discharging circuit that I mentioned. So this capacitor, I charged it fully up to 9 volts. You can see this is now connected in series with a resistor and a LED. So now the electrons that we discussed in the discharging circuit, they must pass through this resistor, through the LED, and they will reach to the other plate of the capacitor. So this is what going to happen. As the electrons reaching towards the other plate, the voltage decreases. As a result, the current decreases, and you can see, and you can observe from this experiment, the light will also fades out. As the current decreases, the light will also fades out, and when the capacitor discharges finally, the light won't glow anymore. So this is the discharging procedure. You have to observe that this light initially will glow brighter, and it will eventually fades away. So now I'm going to connect this circuit. So observe it carefully. Sorry. Yeah. Look at that. From the initial brightness to the capacitor is discharging through this path and towards this plate. You can observe that. So this is the beauty of the capacitor. So it is used in some Zener, power regulations, and there is a power factor connections, irregular supply of power. We are using this capacitor. You can observe that. See, it is completely out, right? So this is the concept of a capacitor. So thank you guys for watching. Do give your valuable comments and suggestions and do subscribe and like. Thank you.